Okay, so we are getting to the point now where we're going to start talking about how do ocean waves carve the coastlines of the continents. And so one way that this happens is because of wave action. Another thing that can be doing it though is the tides. So I want you to have a understanding of what the tides are, what do the tides look like, and then what is it that causes the tides. Now this is very complicated, very mathematical, and so if you really want to have a good understanding of this, take a oceanography course, and then they will explain the tides in more detail. So we're going to have a much more simplified view of what causes the tides. So if you pretend that this is the Earth, okay, and then over here is the moon. So hopefully you already know that it's the gravitational pull of the moon on the water that causes the tides. And so if there was no moon, then this would represent the oceans. And so the oceans would be uniformly distributed around the Earth. All right, so now let's include the effects of gravity. So I'm hoping that you know that it's going to, now this is greatly exaggerated, but you'll notice that this water over here on this side of the Earth is being pulled towards the moon. Okay, hopefully you know that. Now, what you may not know though is that there is another bulge on this side over here. So if we continue this around, there's an identical bulge on this side that corresponds to the bulge on this side over here. So you might be thinking, well, that's because of anti-gravity. So the gravity is pulling on the water over here, and then the gravity is pushing on the water over here, and so that's making that bulge. No, that's not correct. So what's really happening is that the gravity of the moon is pulling on this water here. The gravity of the moon is pulling on the actual rocks of the Earth. So it's pulling on the geosphere as well. And then the gravity is pulling on this water on this side over here. Now look at the distances that are involved. So you have a short distance, a medium distance, and then a long distance. And when we talked about, in a previous lecture, we talked about gravity, and we said that the force of gravity was proportional to mass 1, so that could be the moon, mass number 2, that could be this water right here, and then divided by r squared, where r was the distance between the water and the moon. So because this is a shorter distance, if you put a small number in for r, then what comes out is a big F. So this one is going to be experiencing the largest force because of the distance. And now this one down here has the longest distance, so it's going to be experiencing the smallest amount of force. And then this one's going to be in between. So what happens is this water is being pulled towards the moon. The Earth is being pulled towards the moon, but not as much. And then this water is also being pulled towards the moon, but not as much as the Earth, so it kind of gets left behind. And so that's the reason why you've got these two tidal bulges. Now that was the simplified version, okay? So if you really want to know what is it that's causing the tides, and you have to know something about mathematics and vectors in order to understand this, take an oceanography course, but this is going to be good enough for us. Another thing I'd like for you to know is that the sun also pulls on the oceans. So that here's the moon over here, and let's just say for the sake of argument that the sun is over here. Now this again is greatly exaggerated, but let's put the sun over here. Then you would have extra tall tides. So then the tides might look something like this. So they would be extra tall on both sides of the Earth. and that's going to be called a spring tide. So a spring tide. But what about if the sun was over here? So if the sun was located over here and the moon was located over here, what would happen? Well, the water would want to go this way because of the moon, and the water would also want to go this way because of the sun, and then you would get extra small tides. And then that's going to be called a neap tide whenever that happens. Those are the tides. Oh, and then, now in addition to this, these bulges, they don't stay put because the Earth is rotating out from underneath the bulges. So from the point of view of us living on the Earth, it makes it look like the bulges move around the Earth as the Earth is rotating. So that would mean that at high noon, when the moon is directly over your head, then that's when you're going to have a high tide. But you're also going to have a high tide 12 hours later when the Earth rotates around. So you're going to have a high tide approximately every 12 hours because of the rotation of the Earth. So the moon could either be directly over your head, or the moon could be directly underneath your feet on the opposite side of the Earth. And either way, it's going to produce a high tide. Now, having said that, that's not quite correct, because the problem is that as these tides are trying to move around the Earth, they bump into the continents. And so what actually happens, don't worry about this, not going to be on the exam, but what really is happening is that in the middle of the oceans, there are these mounds of water that are rotating. And then as those mounds of water rotate into a continent, that's when you're going to experience a high tide. So if you're really interested in this tide stuff, take an oceanography course. Okay, but the main thing that I want you to get out of it is the tides are caused by the gravity of the moon and the sun, and it's going to cause two tidal bulges, and then those tidal bulges, as the Earth is rotating out from underneath it, it makes it seem like those bulges are moving around the Earth, and then when they bump into a continent, that's when you have your tides. All right, let's take a break, and when we come back, we're going to talk about global ocean circulation.